Welcome to JS Production, and today I'm going to introduce to you to JS Tuitions. So we have actually started our online tuitions, and it is referred to as the JS Tuitions, and we are offering subjects like mathematics, biology, chemistry, and physics. And how this is taking place is that you need to make a monthly payment of 50 kwacha per subject. After you make that monthly payment, you're going to be added to a WhatsApp group depending on the subject that you have paid for. Take for instance, if you have paid for biology, you're going to be added to a WhatsApp group for biology. And in those groups, what we are doing, we are actually looking at different topics. So make sure you come so that you might not miss out, and so that you can be prepared for the exams. In these videos, I've also placed some videos that we have done, so you can check them out. Yeah, so yesterday we actually talked about the earth geometry in mathematics, and we actually looked at different things. We actually looked at the definition of earth geometry. We actually talked about the latitudes and the longitudes. We also talked about on how you can locate the places on the Earth's surface. We also talked about on how you can find the difference in latitude between two places. We also talked about on how you can find the difference in longitude between two places. We also looked at on how you can sketch the Earth's surface. So today we are going to proceed. We're going to talk about on how you can calculate distance. So there are two ways in which you can calculate distance. You can calculate distance between two places that are sharing the same latitude, or between two places that are sharing the same longitude. So to start with, we are going to talk about on how you can calculate distance between two places that are sharing the same longitude. So the formula that you use when calculating distance between two places that are sharing the same longitude, you say distance is equal to length of the arc is equal to theta over 360 multiplied by 2 pi r. And the r that you write in the formula is the capital letter R. So theta represents the difference in latitude between the two places. Theta represents the difference in latitude between the two places. Then the pi is actually given in the question as 3.142 in paper 2 or 22/7 in paper 1. Then the capital letter R represents the radius. So the radius is given in the question as 34.37 in nautical miles or 63.70 in kilometers. So I've already written the formula, so I'm going to take you through this formula. So I've said when calculating distance between two places that are sharing the same longitude, you say length of the arc is equal to theta over 360 multiplied by 2 pi r. So the theta here represents the difference in latitude between those between the two places. Then the pi, I've said the pi represents 3.142, which is given in paper 2, sorry, or 22/7, which is given in paper 1. Then r represents the radius, and the radius is also given in the question as 34.37 in nautical miles or 63.70 in kilometers. So this is the formula that you use when calculating distance between two places that are sharing the same longitude. Let us now look at on how you can calculate the distance between two places that are sharing the same latitude. So the formula that you use when calculating distance between two places that are sharing the same latitude, you say distance is equals to the length of the arc. The length of the arc is equals to theta over 360 multiplied by 2 pi r. In this case, the r that you use is the small letter r. And the thing that you're supposed to know is that theta represents the difference in longitude. Then the pi, you'll be given the question as 3.142 in paper 2 or 22/7 in paper 1. Then the r, the small letter r actually represents the capital letter R cos x. So let's go through this formula. So I've said the formula that you use when calculating distance between two places that are sharing the same latitude. You say length of the arc is equal to theta over 360 degrees multiplied by 2 pi r. So the theta represents the difference in longitude between the two places. Then the pi is 3.142, which is given in paper 2, or 22/7, which is given in paper 1. Then the small letter r represents the capital letter R cos x. So the capital letter R represents the radius, which is given as 3437 in nautical miles or 6370 in kilometers. Then the x represents the latitude where those 2 points are. So tomorrow we're going to look at the example that you can use to calculate the distance between two places that are sharing the same latitude, or the two places that are sharing the same longitude. Thank you very much. So yesterday we studied the topic of excretion in biology, and we actually defined what the excretion is. We actually talked about the importance of excretion. We actually talked about the process of excretion. We also looked at the structure of the urinary system. We also looked at the internal structure of the kidney. So today we're going to proceed. We're going to talk about the structure of the nephron. So each capillary is supplied with oxygenated blood by the arteries. So the arteries, when they enter the kidney, they subdivide into the arterioles, and the arterioles, they further subdivide into the capillaries, and thousands of capillaries, they form a knot which is referred to as the glomerulus, and the glomerulus are surrounded by a cup-shaped structure which is referred to as the Bowman's capsule. So the Bowman's capsule leads to a core tubule referred to as a rhinotubule, and after several turns and cause, the rhinotubule leads to a common collecting duct, and the common collecting duct, they pass through the medulla. After passing through the medulla, they pass through the pelvis. After passing through the pelvis, they go out of the kidney through the ureter. So all these structures that I've said, these are the structures that form the nephron. So I'm going to write the points that I'm just saying. So I've said each kidney is supplied by oxygenated blood by the arteries. So the arteries supply oxygenated blood to the kidneys. Then the arteries, when they enter the kidney, they subdivide into the arterioles. So the arteries subdivide into the arterioles. Welcome to JS Tuitions. So in physics, we're going to start the topic referred to as wave motion. So a wave is defined as a disturbance from one point to another that transmits energy. It is referred to as a disturbance from one point to another that transmits energy. And there are two types of waves. We have the transverse wave and the longitudinal wave. So let me just write these points on the whiteboard. So I've said the definition of the wave. A wave is a disturbance from one point to another that transmits energy. Then I've said there are two types of waves. We have the transverse wave and the longitudinal wave. So the two types, we have the transverse and the longitudinal wave. So we start by talking about the transverse wave. So what is a transverse wave? A transverse wave is defined as a type of a wave where the vibration of the particles are at right angle to the direction of the travel of the wave. So it is defined as a type of wave where the vibration of the particles are at right angle to the direction of the travel of the wave. And the types of transverse wave, we have the light waves and the water waves. Those are the two examples of the transverse waves. So this is a type of a wave where the vibration of particles are at right angle to the direction of the travel of the wave. Then I've given two examples of the transverse wave. I've said light and the water waves. So examples, we have the light and water waves. Let us now look at the structure of the transverse wave. So I'm going to draw the structure of the transverse wave. So as you can see, this is the structure of the transverse wave, and this arrow just shows the direction of the wave. So this part is referred to as the displacement. This arrow represents the displacement. Then this arrow, the point from here to here, is referred to as the amplitude. Then the dotted line is referred to as the rest position. Then the upper part of the wave here is referred to as the crest. The lower part is referred to as the trough. Then the distance between two successive crests. So as you can see, I have the crest here, I also have the crest there. So that distance is referred to as a wavelength. Then this part, the part that I've drawn in black, this represents one wave. So this is one wave. So let us look at the definitions of the parts that forms the transverse wave. So the first part, we have the rest position. So the rest position, this is the region where there is no vibration of particles. So this line, as you can see, this line, it shows that the particles here, they don't vibrate. So that's the rest position. Then 2, I have the displacement. So the displacement shows the direction, and it shows the distance and the direction of the particles from the rest position. So it just shows the distance and the direction of the particles from the rest position. Then I have the crest. So the crest, which is this part, the crest is defined as the highest point of the wave. So the crest is just the highest point of the wave. Then I have the trough here. The trough is defined as the lowest part of the wave. As you can see, my trough is here. So this part, they form the troughs. Then the other way that I have on this diagram, I have the amplitude. So yesterday we studied the topic, the periodic table in chemistry, and we actually talked about the things that forms the periodic table. We said the periodic table is made up of the groups and the periods. We also looked at the physical properties of group 1 elements. We also said that group 1 elements are also referred to as the alkali metals. So today we're going to proceed. We're going to look at the chemical properties of group 1 elements. And the thing that you're supposed to know is that all group 1 elements, they react by losing one valence electron that is found in the outermost shell. So all the elements in group 1, they react by losing that electron that is found in the outermost shell. And when they lose that electron that is found in the outermost shell, they will become positively charged. So let me just show you what I'm talking about. So getting lithium, if you check on the periodic table, lithium, the atomic number is 3. So the atomic number of lithium is 3. And drawing its structure, we're going to have 2 in the first shell and 1 in the outermost shell. So lithium reacts by losing this electron. And when it loses this electron, it will become positively charged. And drawing the electronic configuration of lithium, we can say this is 2, 2, 1. Then another example that I'm going to give is that of sodium. So if you look at sodium, the atomic number is 11. So this means in the first shell, sodium has 2 electrons. In the second shell, it has 8. So 8 plus 2, that forms 10. So I'm just remaining with 1. So when sodium reacts, the one electron is going to lose out and it will be positively charged. And this happens to all the elements in group 1. The other thing that I'm going to talk about is the reactivity in group 1. So reactivity in group 1 increases as you go down the group. So reactivity increases as you go down the group. So what do I mean? So if you check in group 1, we can say sodium is more reactive than lithium. Then we can say potassium is more reactive than sodium and lithium. We can also say rubidium is more reactive than potassium, sodium, and lithium. So reactivity increases as you go down the group.